Hello students. In the previous video, we had seen how to obtain the dot product of two vectors. Today we are going to study a very important topic which is cross product of two vectors. It is used extensively in physics as well as maths. So watch the video till the end. Students, at the end I'll be giving you important points and formula for the cross product of the vectors, which is a very important topic. So watch the video till the end. The cross product, also called the vector product, is defined only for three-dimensional vectors and it results in a vector. This new vector, this resultant new vector is perpendicular to both the original vectors. Its magnitude is equal to the area of the parallelogram spanned by them. Why? Let us see. Here you have the parallelogram which is formed by vectors vector A and vector B, and the angle between them is theta. You know the formula for area of a parallelogram. It is AB sine theta. So that will give you the magnitude of the cross product of the vectors. The direction is determined by the right hand rule, which we are going to see, and the binary operation, this particular operation is denoted by A cross B. That means A cross B is the vector product or the cross product of vectors A and B. The very important part, the formula for the cross product of vectors. It can be defined in two manners. First is the magnitude formula. If A and B are two vectors, then the cross product A cross B is equal to magnitude of A into magnitude of B into sine theta into unit vector n, where theta is the angle between the two vectors and n is the unit vector which is perpendicular to both the vectors A and B. Now, if suppose your vectors are given in the component form, x, y, and z components are given, then A cross B is the determinant which is formed by the components of both the vectors. And you know how to solve a 3 cross 3 determinant. Some observations are there which says that the angle is between 0 and pi. Now, if for any two vectors A and B which are non-zero, A cross B is equal to 0 if and only if A and B are parallel. And this is very easy to note down because when A and B are parallel, then the angle between them will be, say, 0, or you can say pi. So you know sine 0 is 0 and sine pi is also 0. So either they coincide or they are paired. The direction of A cross B is determined by the right hand rule. This is a very important thing. You need determine the direction of A cross B, and in physics especially it is used. So we will just see what is the right hand rule. Now the right hand rule for determining the cross product of two vectors, or it is actually the right handed system which we call. The cross product A cross B, you know it is perpendicular to both the vectors A and B. So now imagine in the three-dimensional space that you are having a vector which is perpendicular to the given vectors A and B. So now this vector, perpendicular vector, can be in any one of the two directions. That means if suppose n cap is your unit vector, then n cap can be in the direction, positive direction or negative direction. So you can have n cap or minus n cap. So you need to determine the direction of your cross product. For using the right hand rule, the first step is position your right hand so your fingers point in the direction of the first vector of the cross product, or specifically align your index finger to the direction of the first vector. Second step is curl your fingers in the direction of the second vector, or specifically align the middle finger in the direction of the second vector. So, how will you get the cross product? Your thumb will point in the direction of the resultant cross product, which is obviously perpendicular to the plane formed by the first two vectors. Also note that in a right-handed coordinate system, the thumb of the right hand points in the direction of the positive z axis if you imagine that your given vectors are in the direction of positive x and y axis. Some properties of cross product, first of all, it is always a vector. Secondly, we have seen that if suppose the cross product gives a zero vector, the only possibility is A and B are either parallel or collinear. If suppose the angle between them is pi by 2, then sine pi by 2 is 1. So A cross B is magnitude of A into magnitude of B. Now suppose if you want to find the angle between the two vectors using the cross product formula, like we have seen in the dot product, if you want to use the cross product formula, sine theta will be equal to A cross B upon magnitude of A into magnitude of B. And it is always true that the vector product is not commutative. Remember, it is not commutative means A cross B is equal to minus of B cross A. Also, if the components, it is given in component form I, j and k, then j cross I is minus k cross j is minus I, and I cross k is minus j. Very important application of cross product. First one is to find the area of a triangle. Area of a triangle is half base into altitude. So in the given triangle, assume that AB is the vector B and AC is the vector A, and theta is the angle between them, and CD is the altitude. So now CDA, or you can say ADC, it is a right angle. So sine theta definition says that sine theta is equal to opposite side upon hypotenuse. That means sine theta is equal to CD upon AC, which is A. So CD is equal to A sine theta. And obviously area of a triangle is always positive. So area of a triangle is half base, which is B, into altitude CD, which is A sine theta. So this is the definition of A cross B. Hence area of a triangle is given by half into magnitude of A cross B. Similarly, area of a parallelogram, you can see in the given parallelogram, AB is the vector B and AD is the vector A, and theta is the angle between them. Over here, you can see that AED is forming a right angle, correct? So sine theta is equal to DE upon A, or DE is equal to A sine theta. By the definition, area of parallelogram is base into altitude. So base is B into altitude, which is A sine theta. So this is the definition of A cross B. Hence, area of parallelogram is given by mod of A cross B. Let us see the difference between the cross and dot product of vectors. The dot product returns a scalar, cross product returns a vector. The dot product works for any dimensions, but the cross product is only for 3D, three-dimensional. The dot product measures how much two vectors point in the same direction, but the cross product measures how much two vectors point in actually the different directions. Let us start with a simple example. You need to find the magnitude of cross product A cross B if vector A is given by I minus 7j plus 7k and B is given by 3I minus 2j plus 2k. So since it is given in the component form, we use the determinant formula A cross B. Means you have to solve the 3 cross 3 determinant putting the values of A and B. So now this is simple. You know how to solve a 3 cross 3 determinant. I into minus 7 into 2 minus 2 into 7. Second vector, you need to put a negative sign. So minus j into 2 into 1 minus 7 into 3 plus k into minus 2 into 1 minus 7 into 3. So hence the resultant A cross B vector is 0 into I plus 19 into j plus 19 into k cap. Remember over here I cap, j cap and k cap are the unit vectors in the three directions. So your cross product is determined by these vectors. So over here A cross B is given by the vector 0 I cap plus 19 j cap plus 19 k cap, and its magnitude is given by under root of or square root of the components, means square root of 0 square plus 19 square plus 19 square, which is square root of 720. Next example, find a unit vector which is perpendicular to both the vectors a plus b and a minus b. So first of all, let us understand this. By the definition of cross product, you get a vector which is perpendicular to both the vectors. So basically you need to find the cross product of the vectors a plus b and a minus b. So first of all, from the given vectors a and b, find a plus b, simple vector addition. 3 plus 1 I, 2 plus 2 j, 2 minus 2 k. So that is vector a plus b. Similarly, vector a minus b. You need a vector which is perpendicular to both the vectors. So let that vector be C. So you need to find the cross product of a plus b and a minus b, these two vectors. So use the determinant formula, put the values. So when you solve the determinant, you will be getting vector C as 16 I cap minus 16 j cap minus 8 k cap. Magnitude of vector C is the under root of the square of the components, means square root of 16 square plus 16 square plus 8 square, which is equal to 24. So what will be the unit vector? We had seen in the previous video also that any time when you want to define a unit vector is nothing but the vector upon its magnitude. So the unit vector in the direction of C will be equal to vector C upon its magnitude. So it is 16 upon 24 I cap minus 16 upon 24 j cap minus 8 upon 24 k cap. Hence, the required vector which is perpendicular to both the vectors a plus b and a minus b is 2 upon 3 I cap in simplified form minus 2 upon 3 j cap minus 1 upon 3 k cap. Also remember, we had seen that you can get the unit vectors in both the directions, plus and minus. So just put a minus sign. Other unit vector can also be minus 2 by 3 I cap, again plus 2 by 3 j cap plus 1 by 3 k cap. Next example. If a unit vector a cap makes angles pi by 3 with I, pi by 4 with j and theta with k, then find theta and hence all the components of vector A. Correct? So first of all, how will you represent a vector A? P into the unit vector in x direction, which is I cap. Similarly, plus q into j cap plus r into k cap. I cap, j cap, k cap are unit vectors. So first of all, angle of A with I cap is given to be pi by 3. So we will be using the formula of dot product over here. So again, recap. Remember, the formula A dot B is given by magnitude of A into magnitude of B into cos theta. Correct? So over here, suppose the first vector you are having is Pi cap plus Qj cap plus Rk cap. Into it is making an angle pi by 3 with I cap. So into second vector is I cap, just I cap. So when you multiply it, what will you get over here? We will be getting equal. And what will be the right hand side? Right hand side will be the magnitude of A into magnitude of B into cos theta by the formula. So magnitude of A obviously is 1. Magnitude of B is 1. And cos theta. Angle is pi by 3. So cos pi by 3 is half. So now when you simplify, it is P into I cap plus Q into J cap plus R into K cap into I cap, means you can write it as over here I cap 1 into I cap plus 0 into J cap plus 0 into K cap, and this is equal to half. So when you it is dot product. So when you just simplify, you'll be getting P into 1 plus Q into 0 plus R into 0. Hence P plus 0 is half. So P is equal to half. So you got the first component for the vector A, which is P is equal to half. Similarly, your vector A makes an angle pi by 4 with j cap. So j cap can be represented as 0 into I cap plus 1 into j cap plus 0 into k cap. The right hand side is magnitude of A is 1, magnitude of B means the second vector is also 1, and into cos theta. Cos pi by 4 is 1 upon root 2. So it is equal to 1 upon root 2. So when you simplify, you get Q is equal to 1 upon root 2. the second component. In the third component, your vector makes an angle theta with k cap. So when you simplify over here, on the right hand side, you will be getting 1 into cos of theta. So that is cos theta. So r is equal to cos theta. So now what are the three components of your vector A? P is half, Q is 1 upon root 2 and r is cos theta. So now the magnitude of your vector A is the square of the components, means root of half square plus 1 upon root 2 square plus cos square. So you will be getting 1 is equal to root of 3 by 4 plus cos square theta. Square on both the sides, so 1 square is 1, and on the right hand side you will be getting 3 upon 4 plus cos square theta. When you simplify, need to know this simplification. So you'll be getting cos square theta is equal to 1 upon 4, or cos theta is equal to plus or minus 1 upon 2. But over here it is said in the given question that over here theta is an acute angle. That means it is in the first quadrant. In the first quadrant, you know, cos theta is positive, all STC, if you remember the rule. So in the first quadrant, obviously cos theta is positive, so cos theta is half, hence theta is equal to 60 degree or pi by 3. Cos 60 degree is half. So you got the third component, r is equal to cos theta, which is cos 60 degree or half. So P is equal to half, Q is equal to 1 upon root 2 and R is equal to half. So the required vector A is equal to half into I cap plus 1 upon root 2 into J cap plus half into A cap. Next example, it is based on the applications we had seen of cross product to find area of triangle and area of parallelograms. In this example, find the area of the triangle with vertices A is equal to 1, 1, 2, B has coordinates 2, 3, 5 and C has coordinates 1, 5, 5. First of all, by the definition of cross product, just now we have seen area of triangle is half into the cross product between the vectors AB and AC. So now you have A and B points are given. Obviously, you know how to find AB, vector AB. It is A to B. That means 2 minus 1 into I. You just have to separate the coordinates of A from B. 3 minus 1 into J cap plus 5 minus 2 into K cap. So your vector AB is I cap plus 2 J cap plus 3 K cap. Similarly, vector AC is 0 I cap plus 4 J cap plus 3 K cap. Now use the determinant form over here and put the coordinates of AB and AC vectors. And when you simplify it, you will be getting AB cross AC as minus 6 I cap minus 3 J cap plus 4 K cap. And what will be its magnitude? Under root of 6 square plus 3 square plus 4 square, so root 61. Hence, area of the triangle is half into the magnitude. So, half into root 61 or root 61 by. Next example, another application of cross product is for finding the area of a parallelogram. The two adjacent sides of a parallelogram are given to you. You need to find the unit vector parallel to its diagonal and also find the area of the parallelogram. See this example, first of all, you need to understand it. It is given that vector A, suppose AB is vector A and AD side is represented by vector B. Direction is important over here, correct? So now, first of all, if we want to find the unit vector for the diagonals, then first of all you need to find both the diagonals. So which are the two diagonals? The two diagonals, as you can see, are AC and DB. Remember, direction matters over here. First of all, your diagonal AC. By the triangle law of addition of vectors, what do you get? AB plus BC is equal to vector AC. Again, I am telling you, take in mind the direction. So AB plus BC will give you AC, which is one of the diagonals. So if AD is B, then BC is also vector B, because you know they are opposite sides of a parallelogram, correct? So over here, AC diagonal will be vector A plus vector B. The second diagonal is DB, correct? So how will you get DB? DB is DA plus AB. Now Again, I'm telling you that it is not commutative, cross product is not commutative. Hence, AD and DA, they are both opposite vectors. So what you will be getting it as DA is minus of AD, that means minus B vector. So your diagonal DB is minus B plus A, or you can say A minus B. Correct? Then by simple vector addition, you can get the components of A plus B and A minus B vectors. Now we want unit vectors parallel to the given diagonals. So first is A plus B diagonal. Hence A plus, how will you get unit vector? By definition of unit vectors, it is the vector upon its magnitude. So A plus B upon magnitude of A plus B. So that when you simplify, you will be getting 1 upon 7 into magnitude is 7. So 1 upon 7 into 3 I cap minus 6 j cap plus 2 k cap. Similarly, unit vector in the direction of the other diagonal A minus B will be A minus B upon its magnitude. So that is equal to 1 upon root 69 into I cap minus 2 j cap plus 8 k cap. So we have obtained over here the unit vectors. Now to find the area of parallelogram, it is given by magnitude of the cross product. So first of all, just put the components, solve the determinants. When you solve the determinant, you will be getting A cross B as 22 I cap plus 11 j cap plus 0 k cap. And what will be its magnitude? Square root of 22 square plus 11 square plus 0 square, or it is root of 605 root of 5 into 121. 121 square root is 11. Hence, the area of the parallelogram is 11 into root 5 square units. Next example. This is an important example because we are going to get important formula at the end. So, try to understand it. Write down a unit vector in xy plane making an angle of 30 degree with the positive direction of x-axis. So now over here you can see in the diagram that suppose OP is your unit vector in the xy plane which makes an angle theta with the positive x-axis. So first of all, the magnitude of OP, since it is a unit vector, its magnitude is 1. Now by the triangle law of addition of vectors in triangle OMP, you know angle M is a right angle, and in the triangle OMP, OP can be written as OM plus MP. Now by the definition of unit vector, how is unit vector defined? Unit vector A cap is equal to vector upon its magnitude. So your vector is magnitude into the unit vector. Hence, vector OP is equal to OM, which is the magnitude of the vector OM. So vector OP is equal to OM into I cap plus MP into J cap. Correct? Next thing is you right hand side you multiply and divide by OP. So you will be getting OP into OM upon OP into I cap plus OP into MP upon OP into J cap. But what is OM upon OP? What is the definition of cos theta? Cos theta is equal to adjacent side upon hypotenuse. So over here OM upon OP is adjacent side upon hypotenuse. So that is nothing but cos theta. Similarly, sin theta is defined as opposite side upon hypotenuse. So sin theta is MP upon OP. So you will be getting your vector OP as cos theta into I cap plus sin theta into j cap. So it's a very important formula which can be used in other examples. The formula for getting the unit vector along a line making an angle theta with the positive x-axis is given by cos theta into I cap plus sin theta into j cap. Next example, it is an application of the practical application of the cross product. Let us see how. So over here, you are having a girl walks 4 kilometers towards west, then she walks 3 kilometers in a direction 30 degrees east of north and then stops. Determine the girl's displacement from her initial point. So first of all, suppose the girl is at initial point O, which we can consider as origin. Then she walks 4 kilometers towards west. So OA, the magnitude of vector OA is 4. Then from there she moves 30 degree east of north. So suppose AN is pointing towards north from the point A, then she goes 30 degrees east of that. Correct? So your vector AB, which is formed by 30 degrees east of north, then vector AB over here has magnitude 3. It is given over here that she walks 3 kilometers. So the magnitude of vector AB is 3. Another thing is the angle BAO will be 90 degree minus 30 degree, which is 60 degree, because over here we want to evaluate the triangle BOA. So the angle from NAB is 30 degree, hence the angle BAO will be 60 degree. Now over here what we are going to use is the formula just now we had derived, that a unit vector along a line making an angle theta with the x-axis is cos theta into I cap plus sin theta into j cap. Now the direction over here is in the direction of the positive x-axis, and as I told you, if you shift it on the other side, you can evaluate it properly. So now the girl's displacement vector from her initial departure, this we want to find, means basically what do you want to find? 0 to b. You want to find the magnitude of vector OB. You want to find the magnitude of vector B. And it is given that vector OA is in the direction of west, in the west direction. So if we consider O as the origin, then OA vector will be 4 into minus I cap. Why minus? Because we are going in the negative direction from the origin. So it is minus 4 I cap. Now for AB, by the formula just now as I told you we have derived, theta is the angle between AB and OA. Then the unit vector is given by cos theta into I cap plus sin theta into j cap. Theta is 60 degree. So we'll be getting over here AB as magnitude of AB into its unit vector. Again, this is the definition of unit vector. Unit vector is vector upon its magnitude. So what is the vector? Vector is magnitude into unit vector. Magnitude of AB is 3 given into unit vector by this formula cos 60 degree into I cap plus sin 60 degree into j cap. So when you simplify, you will be getting 3 by 2 I cap plus 3 root 3 by 2 j cap. So you have got your vector AB, correct? So by the triangle law for addition of vectors, what is OB? You want to find OB, but what is OB? OB is OA plus AB. OA we have seen minus 4i plus AB we have just now obtained. When you simplify it, we'll be getting vector OB as minus 5 by 2 I cap plus 3 root 3 by 2 j cap. Hence the girl's displacement is given by the vector minus 5 by 2 I cap plus 3 root 3 by 2 j cap. And if you want to know the magnitude of the displacement, it will be equal to root 13 kilometers. So for solving examples on cross product of vectors, remember this formula. Do share the video and subscribe to the channel for topics of mathematics class 9, 10, 11, 12. I'll be giving the link of the other two videos on vectors in the description box.